Question number 9 is parametric equations in terms of x and in terms of y. And this is an inverse sign, so dx dt is 1 on the square root of 1 minus t squared. So the first part I have to show that dy dt squared is going to be in this form. So I've got to take the derivative of this, which is what I've done. The derivative of the logarithm is 1 over the inside times its derivative, which is 1. Derivative of this logarithm is a quarter, 1 minus t, but the derivative of negative t is negative 1. And then I need to square it, so we'll end up with 3 terms. This term squared, 2 times the first times the second, which gives you this, plus the last term squared, and putting it all together in this form here, I can see that a equals 1, b equals negative 2 because the 4 and the 2 will cancel, and c equals 16. Now I've been able to do that because when I find this arc length, this is what I need, and I can use this as a substitution, and of course dx dt squared will be this squared, which is 1 on 1 minus t squared. Now when I place all this together, I've got 4 things, but I notice that I've got a 1 on t squared and a negative a half of 1 on t squared. I can combine them together to give me positive a half of 1 minus t squared, which I factorized into 1 minus t and 1 plus t. Now I'm thinking, what's going to happen here? What's going to happen here? Because I've got the square root and I can't integrate these things, I would like to form the perfect square so I can take the square root of the perfect square. So I've turned this into, that joined with that. This I've written as 1 on 1 plus t all squared, and this I've written as a quarter 1 minus t all squared, and 2 times this gives me this exact same thing in the middle. Therefore I've got this perfect square. Therefore the square root of the perfect square is this integral, and that gives me these logarithms, which gives me this answer. And I can have a plus or minus a quarter as being the answer